Oh boy, this one could be interesting. All right, so let me show you guys where we're at. We've got a shaft here. This goes to a pump. So it's a pump shaft, stainless steel. And this section from this groove to here, and it looks like it's about a 1/4 inch thick. This is a sleeve. As you can see, the sleeve is damaged, and this sleeve needs to come off. There's a little bit of damage right here that we're going to repair, but this sleeve needs to come off. So that's going to have to be pressed off. I have an arbor press, and I think it's a 2.5 ton, but I don't know that that's going to be enough to get this off. I think the better route to go is going to be, we're going to do it here on the table, and we're going to use a porta power to press this out. I do have a shop press on the want list for the shop, but it's 10 grand and I don't really have that right now. So we're going to do it here on the table. Sometimes doing things like this on the table can be easier. I do think in this situation, this is probably the best way to go. And I say that because of this groove. So you can see that's like a tapered groove on this side. So what I'm going to do is I'm going to take and burn a piece of plate with like a doghouse shape, and I'm going to weld that to the table, and then I'm going to take my porta power and I'm going to weld a backer plate here, something to push off of, and then we'll see if we can push that out. We may end up having to heat that sleeve up just a little bit to get this to bust loose. I'm hoping this will go okay. We may have to reinforce our little doghouse piece that's going to hold that sleeve in place, but we'll see how it goes. Maybe it'll go easier than we think, but typically it just doesn't go that way. We'll go ahead and we'll get all set up. Bridger's cleaning up the table from previous projects, so we'll get the table all cleaned off. I'm going to go over and burn our little doghouse piece, and then we'll come back over here and we'll see if we can't get this set up. So the tricky part about this is going to be making that radius just big enough that it's not hanging up the shaft, but big enough that it's going to hold back the sleeve. So we're going to go 1.13/16 on the height, and then we'll have to go 1.4 on the width of that. Calipers don't really fit down in there perfect. Yeah, we'll go 1.4. And that should be all we need. And then I'm going to have the flanges on it pretty wide because I want some strength to it. And if I need to bend some gussets or tack weld some gussets on it to give it a little bit more strength so that we can push that, then we'll do it. So I'm going to go pretty wide, probably, I don't know, 4 inches wide. And then I'm going to have to grind the radius part so that it's got a taper to it. And hopefully that's strong enough that it's not gonna just blow out when we go to press this out. I'm hoping it's not like seized on there to the point where we really have to get after it. And I don't want to put more heat into it than I have to, especially being stainless. So let's go burn our doghouse piece and we'll come back to you. All right, so we've got a bunch of different tools here. I got a band file, I've got my end grinder or die grinder, and I've got a grinder. And I'm going to try to taper this using these tools so that I can get that slid in here. We don't want to put pressure on the main body of the shaft. We just want to put pressure on the sleeve. So I've got to taper this. So bear with me here. We're going to go ahead and see if we can put a taper on this. And this is probably going to take a minute. So we'll speed this up. when we get this all tapered, we'll come back and give you a look. So we need a little bit steeper angle on this. It's coming along good, but I need the angle to be steeper. Oh, oh, money. Don't mind that little faux pas right there. So anyway, we got that tapered. Hopefully you can see what I mean. So there's our taper, and I'm hoping it holds up, but I'll show you guys what we got here. Okay, so if I take this, slide it down on that groove, you can see I've got some movement there. So I know that I'm going to be able to push on this, and it's not holding this piece up because I can still move the shaft. So there's just enough slop there. Okay, so now I'm going to tack this to the table, and then I've also burned these, and I'm going to tack these on here. And then we should be able to start pressing this and see what happens. I'm hoping it doesn't bend the heck out of this and cause a bunch of issues, and then we got to go back to the drawing board. I'm hoping that it'll pop loose, but I guess the only way to find that out is to give her the onion. So we'll grab the welder, get it all set up. We'll get this stuff tacked up, and then here we go. So obviously the weak point on this is going to be this plate, but I am going to put a couple welds here. Give me a hammer. Give me the 4-pounder and that little red square. Okay, so the good thing is I can still rotate this shaft. I want this square as possible. We're trying to cover this because obviously I'm welding with mild steel, but I don't want all that spatter all over the shaft. So we're trying to avoid that. Okay, ready?
Yep.
Just gonna get some tacks on it. Oh. Okay, so you can see the shaft can still move freely, but that sleeve is going to get hung up on this, I hope, and hopefully it won't bend. I'm actually thinking about putting another gusset across the top of this just for some extra strength. Okay, so I found 2 pieces of 3/8 here. Go ahead and weld these on behind the porta-power ram. We want this to push straight. That's why I'm using 2 pieces. Bridger's getting us a piece of 4-inch plate for another gusset here to just reinforce that. So we'll tack that into place, and then we should be ready to hit this. I do think I may heat this up just a little bit, just to try to bust it loose. I don't know what to expect here, so I'm really hoping this works out the way we want it to. All right, guys, sorry, we lost audio, so I had to put the camera back over there and charge it for a minute. We did slide another plate in here and tacked it in place to give it a little bit more rigidity. So we got a plate on top, got a plate underneath, and that should help strengthen this vertical plate. I didn't want to go much thicker here because it would have encroached on this side, the actual body of the shaft. So I've got some plates welded onto the table back here to support the ram. Okay, we're ready to try this. I'm gonna try it first, just try to get a feel, see if it's gonna push it out without me having to heat it up. I'm hoping that's the case. So here we go. I'm gonna try to give you guys the best view possible while I'm doing this. If I didn't mention it before, this is an Enerpack Porta-Power, and it's 10,000 PSI. I can see that plate flexing. Oh goodness. Oh, son of a gun. Come on. Oh, it's flexing. It's moving. Oh, she's moving, but she's flexing a lot. Oh, it's moved. Oh yeah, she's moved. Problem is bending the plate. So it is bending that plate there. You see as the shaft gets pushed, it's bending this. I'm hoping that it holds on long enough. You can see that it has moved, so it is working. I just don't know if this plate's gonna hang on long enough to get the shaft pushed through. It still looks pretty good on this side, but oof. Oh goodness. I'm gonna give this a little bit of heat just to try to help it. And I'm just gonna use like a map torch. I don't wanna put too much heat into it, but I'm gonna heat it up with a map torch and see how that goes. Yeah, she's cold. We're getting some condensation coming off of it. Oh yeah, I can see there's fluid between there. It's starting to heat up. So it's 195 degrees, that'll help. Like I said, I could see the fluid between the sleeve and the shaft and it was starting to heat up. Oh goodness. Oh yeah, she's moving. Come on, baby. You just need that plate to hold. She's coming. She's coming. Oh, woo! Okay. All right, so now we got to stick something in there and just keep pushing. Okay, in this situation, you want to kind of take cover because if that sucker pops out, you don't want it shooting you in the face. Okay, she's still moving, I can see. Now it's to the point where it's safe that I can look at it. So we'll just keep pushing as far as the Porta-Power will let us go, and that's it. Okay. Okay, so I've got that spacer in there, snugged up. We're gonna keep pushing this. Oh yeah, she's moving good now. Woo! Come on, baby. I think we done it. No, let's see. Oh, Bridger, he's Johnny on it. Okay, so we had to switch out our little pusher. This will be the last time, I think. It's pushing good now. Is that it? Oh yeah! Woo! See, she's steaming a little bit. We didn't cause any damage to the end, to the threads there, so that's good. Just for reference, it's 130 degrees, so it's not like so hot that it would cause it to warp. Yeah, I can almost keep my hand on it. And I know from the process that they run that that's not anywhere near as hot as it usually gets during normal operation. So now I want to give you guys a look at this contraption we built. Okay, so I hope you can see how bent that is. I mean, it flared that sucker for sure. But I was sure glad that it held on as long as it did. Even if I would have had a shop press, I'd have still had to build some sort of apparatus to wrap around that groove and set it on the plate. It would have had to have been wide enough, and it would have had to have been one piece, plus I'd have probably had to put a backer plate on it and weld that up, and done the same thing and pushed it down. So you basically would have still had to build some sort of apparatus to get that off. I'm eventually going to end up getting a shop press. I know exactly which one I want, but you know, shop equipment's expensive, so sometimes you have to make do with what you have, and that was a good lesson here. We didn't have a shop press, but we did have a porta power, and so we made that work. I've done this numerous times. It's also one of the reasons that it's nice to have a steel plate table that you're not afraid to weld to. I love my Fireball tool table, and I eventually would like to get a bigger one, but it is nice to have a steel plate table in the shop for things like this as well, if you do this sort of work. Sometimes you need a piece of plate or a table that's big and heavy that you can weld something like this to and not have to worry about messing up the surface. And you would never want to do this to a Fireball table, but it's just what the table was built for. So I think we won that battle. So now we've got to repair the grooves that are in the front of this shaft. So we'll get all set up and we'll come back to you and show you how we're going to do that. All right guys, so let me show you where we're at now. I've put the shaft in the lathe and I put a dial indicator on it. I always like to get a bearing or a reading on how straight it is before and after. These are the types of projects where you always get a lot of armchair quarterbacks, and you always get a lot of professionals out there that want to say, you can't weld on that, it's going to warp. But I've done this on several of these shafts and I've been able to get away with it, and I'll show you guys how I do it, but I just want to show you I am getting a reading on how straight it is before and after, and we'll show you before and after so you can see. If you're really careful about the heat, you can get away with it. Obviously you can't put too much heat into it or it will warp, but we've got two grooves here we've got to repair. It's the only way we can do this. So if the customer is going to be able to use this shaft again, those two grooves have to be repaired. If I can't repair them, then it's junk. So a new shaft, for them to purchase a new shaft, it's $1,200. So they wanted to see if we could get away with repairing this first, so we're gonna try it. I'm gonna have Bridger zoom in on the dial indicator here when I start the lathe, and you'll be able to see it's got 1/1000th of run out, which means it's out of concentricity by 1/1000th of an inch. So here we go. Okay, so it's got 1/1000th of run out. So now we know before it had 1/1000th, we're gonna fix it, or we're gonna try to fix it, and then we're gonna come over here and we're gonna check it again. We're gonna chuck it the exact same way. I tried chucking it the other direction, and it was really hard for me to get it centered. So I grabbed it by the tail end here and put the dial indicator on the opposite end. You always want to try to be as far away from the chuck as possible to give you the most accurate reading. That was this surface right here. So we'll go ahead and get set up over on the table. We're going to throw this in the weld positioner. I'm going to get the Dynasty set up, and we're going to have to run a pass on this to fill those grooves back up. Then we'll have to bring it back, put it in the lathe, and we're going to have to machine this back down flat. We've got to get readings on the OD of this surface so we know how far we can build it up and how far we got to bring it back down to, and we cannot go past that. It's a very delicate operation. Let's see what we can do. So I've got a micrometer here, and I've got to get this reading. Right here on the end of the shaft is an accurate place for me to measure what the diameter of this shaft should be. 1.749. So 1.749 inches, that's where we need to be. So I'm gonna write that down real quick. I'm probably gonna hit this with some Scotch-Brite, clean that up a little bit, maybe with some rubbing alcohol or some acetone, and then we'll go ahead and start running a bead on it. I believe this is a bearing surface. Hopefully, if everything works out the way we want it to, you won't even be able to tell that there was an issue here. So I'm gonna run one pass, just one complete pass, and then I'm gonna let it cool completely, and I'll come back and I'll run the second one. I'll run it, and then I'll let it cool completely before I machine it. And that'll be the moment of truth when we'll be able to tell if we got any warpage or not. So that's the plan. All right, so here we go. I've got my pulsar set, and I've got it set on 75% peak amps, 25% background. I'm running a Furic number 10 cup with a gas lens. I've got my 332 tungsten sharpened to a needle point. My weld positioner's set on about 7 on the speed. Okay, let's try this. Okay, the first one wasn't the greatest, but I'll give you guys a look here. Okay, so you can see we did fill up the first groove. Got a little wavy on me. And I had to turn up my speed twice to get it to kind of fill in the way I wanted it to and try to be as consistent as possible. And it did get better. You can see this section right here coming up got a lot better. I was more happy with that, but sometimes it takes a minute. The second one should go a lot better. Like I said, we're gonna let this cool now. The point of running pulse is it hits in bursts. So you get 75% of your amperage, and then it cools off to 25, and 75 and 25, 75, 25, 75, 25. And so that helps you avoid as much heat being input into the part. This is where pulse shines. We'll let this cool. Once this cools, we'll come back and we'll run another in that second groove. It's gonna be a minute, we'll come back to you. All right, pretty much back to room temperature. Feels good. This other groove to repair here. Everything looks good. It looks like we filled up our groove there. And then I'm gonna fill this other one up. So there's actually a little shoulder here that I didn't want to get into because I didn't want to have to screw that up. And then it steps down to another diameter here. So I don't want to get into this shoulder because I don't want to mess that up. So I've got to keep things back this way of this shoulder. Now that I got my speed figured out a little better, we're actually running about 16 on our speed on the weld positioner. That was kind of the sweet spot after I turned it up a couple times. So there's a lot of things going on when you do this sort of thing. There's the speed that your weld positioner's set at. There's your background amperage, your peak amperage, machine amperage. So there's a lot of things going on there, and you got to get everything set just right to where it gives you the results that you want. Got to fill up this other groove here. So here we go. Running a lot better. And you guys will see when I show you the results. I got this dialed now. I like the speed that it's going. Okay, so you can see Got it pretty much dialed there. I like the way that turned out. Filled in our other groove. So now we'll just let it cool. It's pretty amazing when you sit and kind of monitor what the heat's doing in a shaft like this. I've got all this mass, all this cold metal right here. So it sucks up a lot of the heat out of this thinner portion of the shaft. And then this heavy part right here actually soaks up a bunch of the heat as well. So it kind of pulls the heat and transfers throughout the whole shaft. So it's interesting to see what the heat does in a shaft like this that's got different diameters. Anyway, just kind of nerding out about that. But we'll let this cool. When it's done, we'll go over to the lathe and we'll give you an update on what's next. Okay guys, we got the shaft put in the lathe here. We got our dial indicator on it. It's set up the exact same way. We did get 1/1000th of an inch warpage. So that's about the best I could get it. But instead of 1/1000th, now we're running about 2/1000ths. That's still not bad. So I'll show you on the dial indicator. Now obviously it's not perfect, but it's not bad either. So I'm gonna go ahead and start machining this off, and I'll just take my time, go slow. We know what our measurement is, so we'll just start taking a few passes off this and see if we can't get it machined back down to factory. So here we go. Okay, so here's what it looks like after one pass. So you can see where the weld is. And hopefully you can see that shoulder right there. So we don't want to get into that shoulder. This is one diameter, and then this section's one diameter. So we're just going to keep whittling away at this till we get close to our dimension. So I'm going to pull a measurement on the top of that weld and see where we're at and see how much we got to take, and just go really slow. All right, so we've got about 40 thou we got to take. I'm actually going to speed this up a little bit. We got to take about another 7 thou off. I like to measure it in a couple different places just to make sure. Okay, so we got about 1,000th to go. It's just barely got to come down. So I'm going to grab some emery cloth and then we'll clean it up with some Scotch-Brite. Okay, about 2/1000ths. But I want to see what kind of run out we're getting in the center of the shaft. I want to check it in a couple different places. It's about 1.5 here. So right where we welded it, it's about 2/1000ths. Center of the shaft's about 1.5. Let's check this end. This is actually where we checked it before we started, and it's got 2/1000ths run out there. So it did warp 1/1000th of an inch. Okay, so here's something else they asked me to do. They had to use a pipe wrench to get this off, and you can see there's some pretty good scars there. So I'm going to hit that with some emery cloth. I don't believe there's anything crazy that mounts on this end right here. I can see, looks like there was a set screw right here that maybe they forgot to undo. I don't know, but you can see there's a drag mark right there. Anyway, we'll hit that with some emery and then we'll see if we can smooth it up. Okay, so the last thing, I just want to clean it up with some Scotch-Brite. So I'm going to take this and hit all these spots, just kind of polishes it up. The customer actually ordered a new one, and they put the new one in, and they're going to use this as their spare. So I'm just going to polish this up. You always want to be careful when you're doing stuff like this. You don't want to put your fingers anywhere where they could get snagged. And if you get to the point where you're getting too close to the chuck, then it's time to reset. I'm actually going to grab a wire brush and just brush out those threads. That just cleans all the crud out of those threads, polishes them up. Okay, now I'm going to flip this. I want to polish the tail end of this. Okay, I think she's looking pretty good here. All right, guys, got our shaft done. You can see this is the surface from that little groove, from that little teeny step right there to this corner. That's what we built back up. So they should be able to use this shaft again. Now, like I said, it did get a little bit of movement, about 1,000. That should be okay. I'm going to check with the customer and I'll let him know, hey, this does have 1,000th of movement of warpage. Most pumps like this will have a variance. They'll have a certain amount of movement that they can have before it starts causing catastrophic damage to the components on the pump. I do believe if there's less than 2,000ths run out, it should be fine. There should be clearance. It should be fine, but I am going to check with the customer and I'll let them know this is what we got. So this is a pretty challenging repair. It's kind of fun. It's definitely one of those technical jobs. So I think that's going to wrap this one up. Remember that having the right tool for the job makes a difference. Thanks for watching. See you on the next one. All right, so let me catch you guys up. I do have a shop press on the list. It's a 50-ton, and it would do the job just slicker. We didn't have a shop press, but we did have a porta power. For this, I've done this numerous times, and it's what choking on my spit. It's just, so we'll go ahead, we'll get it. One of the tricky things about doing this is you got a lot of things going on. You got your pulse, your background amperage,